In this video, I'm going to show you how to create Candy Crush in Java. Before we start the video, I just want to say that this might not be the best way to create Candy Crush in Java or any other language. So I'm only showing you how I did it. If you have any ideas or ways to improve the game, then I would love to see them in the comments below. And the game is not going to have any animations, so everything is going to be instantaneous. If you guys want to see another video where I explain how to do animations, then leave it down in the comments below. Now, let's get started with the video. So the first thing I'm going to do after creating the Visual Studio project, I'm going to create a new class. Let's call it game.java. And this is where we're going to write all our code. Let's actually create a run function or a method. Void run. And this is what we're going to call from this class to execute the program or the game. So I'm going to create game, call it game, game. And then I'm going to just call the run function. And everything that's going to happen is going to be associated with this run function. Let's just create a G-frame. This is where we're going to show, this is how we're going to show our window. G-frame, let's call it frame equals new G-frame. Make sure the imports are all set like this. Actually, let's just import everything from Swing, because we're going to need a lot of classes from there. And let's say frame.set visible true, so we can show this window. Now if I just run the program, we're gonna have this window right here. But as you can see, like, it's really small, and when we close the window, the program is still running. So we need to solve that real quick. And to do that, we just do frame.set default close operation, and we set it to frame dot exit on close. So this will close the program once we close our window. And we also need to set the width and height of our window. Actually, let's just put it outside of the run function because we might need it elsewhere. And also, I'm going to create a G panel, and this is basically where we're going to render everything that we see on screen. So let's just call it panel. Is new. Actually, let's just not initialize it for now, and let's just add it to the, let's initialize it here, panel equals new G panel. And the reason why I want to initialize it here is because I need to override a function inside this G panel called paint component. And this is where we can control everything we see on screen. You see, this graphics variable here is what we need to draw things on the screen, like rectangles, images, everything. As you can see, like, there's draw image, draw rectangle, everything we need is in here. So let's just keep it empty for now, and let's add this panel to the frame. So frame.add panel, and let's set the size of this panel. Actually, let's just create some variables that we need here, like the width and height and size and everything. So the first thing we're gonna need to make is the size of our board, and let's do final int size. This is gonna be the number of rows and columns in our board, and I want them to be the same because it's easier to manipulate board that has the same width and height. So for now, I'm going to set it to 8, so that means there's 8 lines and 8 rows, or 8 lines and 8 columns. And the second thing we're going to make is the pixel size of our window. So this is the size in pixels, and let's make it 800 for now. We can change this if we want, like, to make the window bigger, or we want to add more more squares to our board. The third thing is the square size. And this is just going to be the pixel size over the size. Next thing we need to, and actually let's just set the panel here. Hold on. Panel.set the third size, and let's create a new dimension. This is going to have our width and height, so they're both going to be pixel size. And let's also call this function frame.path. Now if we run the program again, hopefully we will have, okay, so it's an 800 by 800 window. Okay, so let's continue creating our variables here. So we're also going to need our background image. So image g equals, so let's not set it for now. And let's of course import this. Let's just import everything from this java.awg. Okay. We also need our, actually I have the images right here. Hold on. So these are all the images we're going to use. We have 6 types of candy numbered from 1 to 6 PNG, and we have our background image, which is PNG, and then our selector image, and this is the image. This is going to be drawn over the selected piece. So we're going to need to define this one as well. Now, let's just find that selector image, selector. And also, we're going to create an array for the other 6 images. You can add other images if you want. We're just going to have to change the size of this array. New image is going to be 6 for now. We're also going to create a random variable. Make sure it's imported as well in here. And what else do we need? We're also going to need a variable for our selected piece. And this is going to be a point select piece. And it's going to be null for now. And that's because we're going to have null mean there's no selected piece. So when this variable is null, that means there's no selected piece. When we select a piece, we set it to this variable. And we're also going to create our board, which is going to be an integer, a 2D array of integers. Board. And it's going to be the same size as this here size. And the reason why we're creating an integer is because it's better to just represent each piece by a number, and it's easier to manipulate that way. So basically, each one of these images is going to have the corresponding number. So this is going to be 1, 2, 3, or we can start from 0 actually. 0, 1, 2, 3, 4, 5. Yeah, so that's our board. Now let's just load up the images. So let's just do a comment here, loading images. And the way we're going to do that is, let's start with the background. So background equals image IO. This is how we're going to read our images. Read new file. And we're going to give it the path of the file here. And actually this needs to throw an exception, so we need to add that to the class. And the path, we're going to just copy it from here. And actually there's a better way to do this, which is to just add the images to this folder here. But that didn't work for me. I think you need to like compile the code by yourself or something. So we're gonna stick with this method for now. The background image is gonna be b.png. Yeah. So this is the background. Let's just draw this image. See if everything is working. Draw image. Okay, so this is the background image. Hold on. And the width and height are going to be our pixel. Oh, actually, this is the x and y, so we'll just set it to 0 and 0. And then the width and height are going to be our pixel size right here. Okay, now if we run the program, okay, we have our background image. Now I want to add a rectangle over the background to make it a little dimmer, because it's a little too bright. So we're going to set the color to new color. Okay, let's use this one, and it's going to be a black color, so everything is going to be 0, but the opacity or the alpha channel is going to have about 200. And let's just copy this, and instead of draw image, we're going to fill rect. So this is just going to fill a rectangle. Actually, we don't need this parameter anymore. So this is x and y, width and height. We also don't need that one. So now if we run our program, okay, we can see that it's a little dimmer. Actually, it's a lot dimmer. I'm gonna maybe turn this down a little bit. Okay, this looks good. Now we're gonna just draw our grid and board at the same time. You can draw them separately, but I think it's better because we need a nested for loop to go through each square. So we're gonna have something like this, and we're gonna have int y equals 0 and y plus plus is just a for loop. It's gonna be a size here. Just gonna copy this, put it here, change this to x. So it's gonna be looping through the x's, and then for each line, it's gonna loop through all the columns. Okay, x. Now let's just draw our rectangle. So g dot draw rect, and it's gonna have the x is gonna be x times the square size. That way, like, we're not just drawing because this x is moving by one value at a time, so we can't just draw it, because then we're going to be moving by 1 pixel at a time. So we need to multiply it by the square size. Same thing for the y, and the width and height are going to be square size. Now if we run the program, as you can see, there's our grid. But I think I'm gonna turn this down a little bit more so we can see it. Let's do 80 maybe. Okay, so now you can see our grid better. And it has 8 squares on both sides. Now we're gonna draw our... okay, actually we didn't load all the images here. Forgot to do that. So we're just gonna copy paste this. This is going to be for our selector image. It's going to be s.png. For the other images, we're going to create a for loop that loops through all possible images we have. Actually, I'm just going to copy this right here. Put it here. Okay, hold on. Okay. And this is going to be our candy dot run. So it's going to loop through all the candy that we have, candy images, and then It's going to set the candy, each candy image is going to set it to, just read this. And instead of B, I'm going to separate this string. Hold on. And we're going to have our Y here. So it's going to loop through all the Y's. Actually, it's going to start from 0. We want it to start from 1. So we're just going to do this. Okay. So now it's going to loop through all the candy that we have. It's going to start from 1. So the first thing it's going to load is 1.png, and then it's going to go through all of them. And we're going to also draw that each image here. So I'm going to have g.drawImage. And we're going to do candy. Hold on. No, it's going to be, it's going to be candy, but we're going to read from the board. So I'm going to do board. So it's going to be Y and X. So what this does is it will read the corresponding square to the X and Y, and then whatever that value is, that's going to be our candy number. So if it was 0, it's actually going to be 0 in the start. So everything is going to be this candy right here, because everything is set to 0. And it's going to draw it on X and Y. And the size is going to be our square size, actually. Let's just set this. So this is the width and height of our image. And also the X and Y are going to be same as this one. Actually, I could have just copied this. Okay. Now if we run the program again, there's actually an error. Yeah, so here we're starting from 1. That's okay for the images, but for the candy, it needs to start from 0. So we can just do -1 here. Now, as you can see, we have all our candy on the screen. If we change, for example, a value from the board, let's say board 3, and we set it to something like, I don't know, 4. So that's going to change. Okay, so we change this one. The reason why it's 4 here, because it's starting from 0. So this is 0, 1, 2, 3. 0, 1, 2, 3. So this is the X equals 3 and Y equals 3 position right here. And it's equal to 4. So that will correspond to this one, because we're starting from 0, 2. So 4 is going to be 5 here, because we're starting from 1. Anyway, actually, I'm going to copy all of this because it's getting a little big. I'm going to copy all this, and I'm going to put it into a render function. And then I'm going to create this function or method. It's also called method in Java. Public render. Actually, let's make it private. Render. I'm going to take graphics as a parameter. It's actually going to be a void. Sorry for mistyping everything. Okay, so this is just not going to do anything. Just better to look at it now, because we have everything structured. Now what else do we need? We're done with the rendering. Actually, we also need to draw our selected piece, or draw the selector over the selected piece. So we're going to see if the selected piece is not null. So if it's not null, that means there's actually a piece selected. And in that case, we're going to do g.drawImage, and it's going to be the selector. selector, and it's gonna have the x and y of the selected piece. So selected piece dot x times square size, and same thing here, selected piece dot y times the square size. Then let's just add the semicolon here. Now, of course, nothing is going to happen if we run it again. That's because there's no selected piece. But if we set the selected piece, say right here, we set it to, let's say, selected piece equals 0 point, let's say 5, just random number like 5, 2, or 5, 3, whatever. Now, if we run, okay, this piece is selected, it's 5 in x and 3 in y, starting from 0, of course. Okay, let's just remove this. Now, I'm going to add a mouse listener. That way we can select the piece when we click on it. So I'm going to do panel dot add mouse listener. So I'm going to put it above this. Doesn't matter the order, but just looks better this way. And we're going to do new mouse. Actually, we're going to do mouse adapter. That way we can just call the mouse clicked, or rather override the mouse clicked method. And when this happens, when like the mouse is clicked, we're just going to call a function or a method called handle click. And it's going to take the mouse event as a parameter. Now we're going to call this private handle click mouse event, and yeah, actually it's going to be a void too. I don't know why I'm forgetting to set the type of each method. Okay, so what this is going to do is it's going to get the x and y in board coordinates. So actually, if we set the x to e.getx, then it's going to be in pixels. So we need to divide it by the square size. That way we get coordinates that we can give to the selected piece. Okay, so let's do the same for y. Get y, and we're going to see if our selected, actually let's just set it straight up now. So selected piece dot, or let's say equals new point, and it's going to be x and y. Now if we run this again, if we click anywhere, nothing happens, and that's because we didn't repaint. So each time you change something something that needs to be rendered, you need to call the repaint function. So panel.repaint. Now if we do this again, okay, so we can select any piece we want. Let's just test if we can do the same if our size was bigger. So let's say 12 maybe. We run it again. Okay, we have 12 pieces. And okay, so this is a problem. You can see the selector is really big. And that's because we didn't set the width and height of the selector, I mean. So it's gonna be the same as square size right here. Just copy this, put it here. Actually. Okay. If we run this again now, okay, everything is working fine. Let's turn this back to 8. Now, actually, we need to, so we need some way to represent empty squares, and I think we're gonna just do negative numbers. So -1 is going to represent an empty square. So we're going to change something in the render here. we need to check for each board coordinate here. So if it's -1, board is less than 0. So if it's any negative number, then we're not gonna show it. Actually, if it's not a negative number, we're gonna do that. If it's a negative number, we're not gonna do anything. It can be equal to 0. And if we set, let's say, something to -1 here, let's say this square right here, set it to -1, 33. Now if we run again, then this square is going to be empty. And we need this later on because we're going to have to set some squares to be empty. Now, let's just set the whole board to empty actually. So I'm just going to copy this right here from the render. This for loop right here. Put it here. Okay. It's gonna set everything to -1. Y and X. So now the whole board is gonna be empty. Okay, but wait. Yeah. So basically, we need to get this one out of the negative check, because we need to draw the lines of our board regardless of whether or not the piece is empty or the square is empty. So now everything is perfect. What else do we need? I don't want to get to the logic yet. I want to make sure everything is fine when it comes to rendering first. So I think actually everything is good. Okay, so I'm gonna create a replace function here. So private void replace, and this basically will take 2 points, A and B, and it's going to replace them in the board. And the reason we need this is because there's going to be a lot of replacement. Every time we click on a piece and click on a neighboring piece, then we're going to replace those two squares or pieces, and we're going to check if there's any matches. Then we're going to continue. We're going to like go on with the replacement and like to handle the like remove the pieces and all. And if there's no matches, then we're going to replace them back. So we really need this replace method here. And basically what's going to do is it's going to okay, so we're going to create a temporary variable, and it's going to be equal to board a.x .y a.x. You can start from x as long as you're consistent. So I'm starting from y because in my mind the arrays has like lines in it. So but if your method of thinking is that the array has rows in it, then you can start from the x as long as you stay consistent. Anyway, okay, so that's going to be equal to that, and then we're going to copy this, and we're going to set it equal to board. Actually, we're just going to paste it again and just change the a to b, and then we're also going to change this one to be equal to 10. So now if we go to the handle click and then we check if the selected piece, actually we're going to just do it right here. So we're going to check if the selected piece is not null. That means there is actually a selected piece. We're going to just replace if it's not null and the x and y of the selected piece are not equal to the x and y that we clicked on. So that and okay, selected piece dot y is not equal to y. So in this case, that means we clicked on a different piece than the one we previously selected. In this case, let's just replace. So replace selected piece with new point x and y. Now if we run this again, okay, of course everything is empty. Now let's also just add another thing here. So if our selected square doesn't have any pieces in it, then we're not going to do anything. So if board x and y and x is bigger than 0, bigger or equal to 0, then that's what we're going to do. We're going to handle the click. If it's not, then we're not going to do anything. Now let's just set some random squares. Hold on. Okay, this is getting a little convoluted. Actually, I'm gonna copy this and I'm gonna create a little function method here. Target void fill, and it's gonna take in a board and choose the array integers. Do a board here, and it's gonna take a number, and it's gonna fill that array with that number. So basically, it's gonna give it this and do I here, and let's set to fill board and -1 here. So this is just gonna fill the board with -1s. And then let's just set a random 2 squares to random pieces. Set this to 1. It's gonna be 3 and not 300. 3 and 2. The other one, let's make it I don't know, 5. Let's set it to 2. Now if we run the program, okay, so if we click here and here, okay, nothing is happening. Okay, let's just check what we did. So if the selected piece is not null, then selected piece is not null, then we replace the selected piece with a new point. Okay. If these are okay, so we have our replace function here. Let's just replace the pieces, see if the replace function is working. So this is 1, 2. Just going to do replace new point 2, 3 with 2, 5. So this is 1, so it's going to be the blue candy, and the other one is 2, so it's going to be the yellow candy. So when they get replaced, we're supposed to be seeing the, hold on, I forgot. So the yellow candy, so we set the blue candy to be on 3, 2, so it's going to be on top. So now we're supposed to be seeing the yellow candy on top. Okay, so the replace function is working. So maybe we did something here in the handle and the click. So this is actually going to be an OR statement, because we're going to be checking either of these. Like if these are both correct, then that's the only case. We're not going to go through this. Or rather, like if the x is equal, the selected pieces x is equal to the x we clicked on, and this is also true, then I don't know how to explain it. Like you can like check it out. You can pause the video and try to understand it. It's like makes total sense. But I'm not sure I can explain it right now. Anyway, you're just gonna write it like this if you don't understand it. And then we're also, after replacing, we're gonna set the selected piece to null. And this is gonna be our else statement right here. Now if we run again, then we replace the pieces, everything works fine. But of course, we need to make sure the piece is on the neighboring squares, so it needs to be somewhere either here, here, or here, or here. So this shouldn't happen. Okay, so to solve that, you need to, actually there's a pretty long statement. Okay, so I'm gonna just paste it. Okay, so this if statement right here, it checks for two things. Actually, let's just remove this here, and also this else statement. And okay, so what this does is it checks if we have a selected piece, and then it checks if it's a neighboring piece. Like if you want to understand this, then you can pause the video and understand it. It makes total sense. But I'm not gonna spend time explaining it because the video is getting a little longer than I expected, and it's just math, like mostly. So you can just copy it if you want. You just have to understand that this checks if the selected square is a neighbor square. Yeah. And if that's the case, then we replace and we set the selected piece to null. If that's not the case, then we're gonna, else we're gonna set the selected piece equal to new point x and y. Now if we run this again, let's just set the board to, hold on, why is this? Yeah, we have a problem here. Something is not closed. Okay. Now, what I was trying to say was, yeah, let's just set like something like, okay. So let's start from the top, and then, actually, let's just set this to 2, and then 2, 1, then 2, 0, and let's just set this randomly to, I don't know, 5, 3, and just get this out of the way, and just set all this stuff to different numbers. Now if we run the program, we can see that these are in the same line and same numbering squares, neighboring squares. And if we click here and here, for example, then it's not going to replace them. But if we click here, then it's going to replace them. Same thing here, here. But now we need to check if our replacement actually is valid. And for that, we need to make sure that there's actually a match after we replace. And for that, we need to go back to our handle click function right here. And after replacing, we need to check if matches. We're going to create this function or method. If matches, and it's going to have, okay, so matches is going to be an array list. Just create it. Actually, I'm going to create it right here. Private matches. It's going to be an array list of points. Let just return an empty square for now. I mean an empty list. So array list. Zero equal 0 array list. It's gonna be point, and we're gonna return the result. And we're gonna check if this is empty. If it's empty, actually, if it's not empty, or actually, no. If it's empty, because there's always two ways to do these things with if statements. If it's empty, then we're going to replace our pieces back. If it's not empty, then we're not going to do anything. Actually, if it's not empty, then we're going to call another function, another two functions actually. One of them is gravity. This will get all the pieces down, and one of them is going to be refill. They are both going to be voids. So this basically will just drop down, or actually I'm going to call 3. And this one is going to be removed, and we're going to give it the matches. So I'm going to create an array list here. Just call it, I don't know, A or matches. Let's just call it matches equals matches. That's going to be a point array, and just going to check this actually here. So if matches is empty, then we're just going to replace it back. If it's not empty, that means we actually had found some matches. In that case, we're going to remove the matches, and then we're going to apply the gravity and then refill the board. Let's just define all these three. We already defined the matches, so remove is going to be private remove. I'm going to give it an array list. Actually, I'm just going to copy this. To remove, and then this basically will just remove the squares that we give it from the board. So it's gonna go loop through the points. To remove, and then it's going to set the board at e.y and e.x to -1, which is what we agreed represents an empty square. So this is the remove function. So if we find any matches, we're going to just remove them immediately, and then we're going to apply the gravity function. Gravity. Yeah, it's going to be a void. I don't know why I keep forgetting that. And then we're going to apply the refill. Private void refill. And also, we're going to have another function, which is the initial filling of the board. Actually, we don't need it. Actually, we can just call refill on the start. So let's just call it right here. Refill. And we're going to just remove all of this. Okay. Now, so the most important function here is the matches. So the way this is going to work is, so the way this matches function is going to work, let me just run the program. So it's going to go through each line, and then it's going to start from this square right here, the second square, or the square at index 1, and it's going to check if it's equal to this one, the one before it. If that's the case, then we're going to add 1 to a variable that we have, and it's the same thing. It's going to go to the next one. Same thing. If it's the same as the last one, then it's going to add 1 to that variable. It's going to keep doing this until either we reach the end of the line or we reach a different piece. So if, for example, here we found that the piece of this square is not equal to the piece of this square, then we're going to have 4 pieces that are equal to each other. So the counting variable that we have, that we keep adding 1 to, is going to have a value of 4 in that case. So we're going to check the count variable. If it's more than 3, then we're going to add all of these squares to our result. Same thing if we reach the end. So if we reach this square and it's equal to all the other squares, or like the number of squares before it, then we're going to just check if the counting variable is more than 3. If that's the case, we add it to the result. Same thing for the columns. We're going to do the same. We'll start from here. Then we check if it's the same as the previous square. Then we add 1 to the counting variable, and then we keep going until we either reach a different square or a different piece, or we reach the end of the column. So this is how our matches function is going to work, and of course it's going to ignore all empty squares. Okay. So since we're looping through all the squares, then I'm going to copy this, put it right here. Okay. So this is going to loop through all the lines. Let's set this to 1 because we said we are going to start from 1 from the second square. And then let's also define our counting variable. So int count line equals, let's set it to 1, because there's always going to be 1 piece. That's so we're always going to start from 1 piece, and then we're going to see if there's a second one that's exactly like it, then we're going to add 1. Now let's check if the piece at at this square that we're on, which is y x, if it's not equal to -1, and hold on, and it's equal to the one before it, equal to the one at x minus 1. If that's the case, then we add 1 to the count line variable, and then we check if it's not the case, if this is not the case, then I'm gonna put it right here. And the reason why I'm not putting it in the else statement, okay, let me just do this, is because we have another condition that will do the same thing, which is if we're at the end of the line. So if x is equal to size minus 1. So if either of these is correct, then what we're going to do is we're going to check if our line is bigger or equal to 3. And we're going to okay, so I have some code that I copied. I'm going to paste here because I already made the game before. Let's do count line here. I'm going to try to explain this, but you can pause the video and try to understand it. So basically, there's a really special case where we reach the end of the line and the last piece is not the same as the previous pieces. So in that case, we need to take away 1 from our, actually no, if the last piece at the end of the line is equal to the 1 at the count line, then we're going to take, hold on, I don't know how to explain it. Hold on. So if the, okay, let's just look at what we're doing. So we're taking 1 from the count line if the piece at the square that we're on is equal to the one before it. But if that's not the case, then we're just going to set it to, we're not going to do anything. So we're not, it's going to be minus 0. And so basically, if we reach the end of the line, just go here. So if we reach the end of the line, let's say these 3 pieces are the same, and this one is also the same, then what's going to happen is the count line is going to have 4 pieces. And the reason why we want to do minus 1 here is because if that's the case, then we're going to start our this loop, which will add points to the result. This loop is going to start from 0 because we're going to do x minus I. Let's do count line here. So I'm trying to explain it as best as I can, but video is getting long and it's kind of difficult to explain. There's definitely better ways to do this, just the way that worked for me. So if you have you want to think about it, maybe find a better way, then of course you can do that. But if you want to follow this way, then you can just copy the code or listen to my terrible explanation of how it works. Actually, I'm just gonna, okay, you can just copy the code at this point, or you can just ask ChatGPT to explain it or find a better way, because the video is getting really long. Sorry, guys. So this, you just have to understand that this checks if we have a match that's more than 3, and if that's the case, then it's going to add all those points to the result. So this will do this for lines, and we're also going to do the same for columns. So count call, just do it here too. Actually, hold on. Let me just choose all of this. And basically, we're just gonna have to change the X and Y in all the, whatever we call the board. Just gonna change this X, Y. Actually, I'm gonna do the same thing I did. Okay, actually, this one is not gonna be same. So these ones are gonna be X. And these ones are gonna be Y. For the other ones, it's gonna be X minus 1. X minus 1. And here it's gonna just be Y. Hopefully this will work. I mean, it's worked before, so hopefully, hold on. We need also to change this one. Okay, so now we're done with our matches function. Let's just run it. Let's just set like a random match. So here we're refilling the board. Let's just set, I don't know, board 0, 1, 2, 1. Do the same for 2 and 3. And then just sys out print matches. Hopefully this will work. I have a feeling that it's not gonna work, but let's check it out. Okay, looks like there's 1, 2, 3. Okay, so there's 6 points, which is of course wrong. I think it's because there's something wrong with the second loop. So this one seems to be working fine, but the other one seems to have a problem. So it's checking X and Y. Okay, X. Okay, actually we forgot a really important detail here, which is that we need to reset our outline to 1 in the case of reaching either the end of the line or finding a square that's not the same as the previous one. And the same goes for count column. Okay, and also since we're looping through the same parameters, then we can just do this in the same hold on, what did I do? Yeah, we can wait, this needs to be here, so this needs to be here, and then we can just remove this one and put this one. Okay, what's the problem now? Yeah, we can remove this one too and put this one here. Hopefully this will work. Actually there's what now? Matches for loop. Okay, we need to put this here. Okay, I think everything is working fine now. Yeah, so we have our printed matches here. So it's x equal to 3, y 0, and then x2, x1, which is the same thing as that. I'm just gonna go ahead and start writing the refill function. And this basically will fill the board. Every empty square is going to fill it. It's going to check for matches. If there are no matches, then it's going to, like, if there is a match, then it's going to change. So basically, it's going to go through every square. And then, so it's going to add a random square here. And then it's going to check if there's any matches in the board. If there's no matches, then it's going to go to the next one. If there's a match, then it's going to change it. So this is basically how it's going to work. So basically, we're going to loop through our board again. I'm going to copy this. And I'm going to remove these two lines because we don't need them. And so what this is going to do is it's going to go to the square that we're on, and it's gonna, okay, so this is gonna be y and x, and this is gonna be start from 0, so it's gonna be equal to a number, a random number, x. Well, it's gonna actually be random, next int, and this will have our candy length. So it's going to be a number from 0 to however much candy we have. And it's going to set that square to that number, and then it's going to check if there's any matches is empty. So as long as this is not empty, it's going to change this. Gonna keep changing it till the matches are empty, and it's gonna do that for all the squares. Actually, let's remove the ones that we added, and let's just call the refill. Actually, we already called it here, so we're just gonna run the program. Okay, thank God this worked. Now, okay, there's a whole thing that happened there. Okay, so we don't have any matches, which is good, which means that our matches function is working and our refill function is working, which is really good. Now, as we saw before, if we do anything, then the whole board is gonna get randomized again. We don't want that, so we're gonna continue doing the logic. So now that we can refill the board, we're going to go to our gravity function. I think that's all we have left, actually. Yeah, so we remove the matches, and then we call the gravity, and then we refill. So the only thing missing here is the gravity. Now, the gravity function, basically what it's going to do is, so it's going to scan the board, it's going to find any empty square, and it's going to move it up one square. So if there's an empty square here, it's going to move it up, and then it's going to call itself again until every last square is either at the top or has an empty square above it. So if we're going to keep adding, if we're going to keep changing this empty square to the one above it, then we're either going to reach the end or we're going to reach another empty square. In that case, we're going to stop. We're going to stop changing the empty square. Hopefully that makes sense. I know that it probably didn't, so sorry about that. I'm terrible at explaining. I don't even know why I'm doing this. I just felt like I wanted to make a video. Anyway, so we're gonna go to, okay, we're just gonna copy this for loop right here, nested for loops. Okay. So basically, if the square that we're on, let's copy this too, is empty, if it's equal to -1, then we're going to set the one up, or so, okay, so we're going to set it to the one above it. So this will be equal to y plus 1. And then y plus 1 is gonna, actually it's gonna be minus 1 because we're going up. And this one is gonna be equal to minus 1. And whenever this happens, we're actually gonna create a variable here, Boolean, called replaced. It's gonna be false. Whenever we replace something, we're gonna set it to true. And the reason why we do that is because if we replaced anything, then we need to call the function again at the end. So if replaced and gravity. So basically, if we move any square up, then we're going to call it again. If we don't move any squares up, what that means is that all squares are at the highest they can be. So in that case, we don't call gravity again. And here we're also going to check if it's empty and the one above it is not empty. So if that's empty and the one above it is not empty, and if the one above it even exists. So if y minus 1 alone, if y minus 1 is smaller than size, or rather smaller than 0, if that's the case, okay, this is going to be or equals. So if this is the case, then we're going to replace our empty square with the one above it and set replace to true. If this is not the case, then we're not gonna do anything. Okay, so actually I'm gonna go back to the handle click method, and I'm gonna remove the refill just so we can see our gravity function at work. Hopefully it works. So let's just find, okay, let's test the general logic. So if I move this here, of course it doesn't work. If I click anywhere else that's not a neighboring square, then it should just go to that square. Of course, like this is also not gonna work. So this should go here and it shouldn't be a problem. So, okay, so it's removed the squares, but it didn't do the gravity. Actually, there's something that needs to be done here. Another thing, which is that when we remove the matches, or rather before we remove the matches, we need to make sure that our, okay, hold on, let me remember what I'm trying to say. Okay, so actually this should be bigger than 0, not smaller than 0. Now, hopefully the gravity function is going to work. Let's just, okay, so it's working. It's working fine. There is, however, a problem. That's what I was going to say before this. Basically, when we check for the matches, actually, let's just put this here and change this to this, and then put that there. Now we're gonna have to recheck, or rather, yeah, so every time we replace, we need to remove the matches and then recheck if there's any new matches. And for that, we're gonna have a while loop. like the one we had in. Okay, so actually right here, I'm gonna have to check if matches is empty. Is empty. If that's the case, then we just put this here. We replace back our piece. And if that's not the case, then that's when we're gonna remove the matches and do the remaining stuff. So basically, when we have matches, then we're gonna remove them and then check again for matches. So here we're gonna put matches equals matches function. Okay, so what this basically does, we're gonna do the refill function after we make sure that there is no more matches. So basically, if there's not any match, then we replace back our selected piece because that's not a valid move. If there are any matches, then we basically remove because there's no matches, then this while loop will run at least once, and it's going to remove the matches, apply the gravity, and then set the matches again. It's going to check for matches again, and it's going to keep repeating until there's no more matches. And only then will it call the refill function. So let's just run this again without the refill. See if it's working. So, okay. You see that there's gravity. Okay, so you see here, this line here, or this column, dropped 2, even though we just replaced this one, and that's because there was probably another match that was found here that was caused by our move. Because, one move can cause multiple matches in anywhere in the board. So it's not like when I move this here, we're only going to have these 3 matches. So we can have, I don't know, like we can have any other matches, and we need to account for that too. Basically here it's not the case, but if that's the case, we need to make sure we remove all possible matches that come from our move. Now let's just enable the refill function. I think we're done actually, because if this works now, then basically we're doing everything. Okay, now, okay, so it's dropping. I don't know if it's correct. Let's just try this one. Okay, it's actually not correct. I don't know what's happening here. Okay, so the refill function. Oh, so it's basically just replacing every square. So that's why in the start or previously I wanted to make 2 functions for filling the board. So one of them is going to be initial fill, and the other one is going to be, and the refill is basically only going to refill empty squares. So if the square is empty, hold on. Okay, so if this square is empty, meaning it's equal to -1, and only then will you fill it. Now let's change this one to initial fill. Wait, I think I spelled it wrong. Let's just call it init fill. Oh, okay. Init fill. Hopefully this works. Okay. Let's, for example, change this one. Okay, something changed here, which I feel like shouldn't happen. Okay, so Okay, so we changed this one and only this portion of the board changes. I think that's a good sign. Let's also do the same here. Okay, same thing. So I think it's working. Same here. The reason why it's hard to check if it's correct is because you have to keep a mental image of the board, the previous board, in your mind, and make sure that when you made your move, nothing else changed that wasn't supposed to. So that's kind of difficult to do. That's why animations are really good for this, and they show you exactly every replacement that happens. But unfortunately, that's beyond this video's scope. If you guys want to see animations, let me know in the comments. This is really difficult to do. So I'm not gonna make the animations now because I don't know if this video is gonna get any views or if there's anyone interested in seeing this kind of games programming and stuff. So I'm not gonna create that yet until I see people who want it. Let's just keep playing for. Actually, one thing I like to do is disable the refill and then just play the game without refilling. So basically I go here, disable that, then run again. So basically I can just play the game, and I'm gonna just, every time I find a match, it's gonna be removed forever. It's not gonna be refilled. So you can also play it like this. Anyway, this is everything for this video, and thanks for watching. Again, make sure you tell me in the comments if you guys want to see a continuation of this tutorial, to include animations and everything else, maybe a main menu, maybe a score. Actually, I should have added a score here. Actually, let's just add a score, actually. Yeah, why not? So basically it's just gonna be integer score, set it to 0, and basically everyone is gonna have different ways of scoring. Maybe for 3 matches you want to add 3 to the score. For 4 matches you want to add something a little bit bigger, like 8 or 10. So basically you're gonna have to go to the actually, one way to do it is just to go to the remove function, and then just whenever we remove a square, we're just going to add it to the score. It's score plus plus, and basically we can just draw the score at the. So every time we change the score, let's just change the title of the frame. So set title score. This is the quickest way to do it. You can also draw it, but I'm getting really tired. Plus score. So every time we change the score, we're going to change the title. Hopefully this won't slow down it probably will slow it down, but it's not going to be noticeable for us. Okay. I think this is let's set the initial title to score 0. Now if we run again, then every time we. Okay, so this is frustrating because there's a match here that shouldn't happen, and this is a really frustrating thing. I don't know what's happening here. I'm getting really tired. Okay, so finally, I can't believe how happy I was when I found this. So we left this line in the code, this replace line, which we used to test the replace function. we left it here, and that's what was causing the problem. So we can just remove that now, and it's gonna work fine. Okay, thank goodness, because that was driving me insane, like genuinely. Anyway, thank you guys for watching. I don't know if I added this core before or after I found. Anyway, I'm not gonna think about it. Thank you guys for watching. If you have any suggestions, or if you want to see any more videos like this one, leave them in the comment below. And thank you for watching.